measuring agreement. In the context of biology, agreement is used to describe the degree of concordance between two or more sets of measurements. It is commonly used when a new diagnostic test or tool is meant to replace a gold standard that is by definition more expensive, more invasive, or not always available. Such as when a simple bedside test of fasting blood sugar replaces the conventional laboratory test, which needs more time and equipment, experienced personnel, and is usually not available 24/7. The bedside test is always available, simple, not expensive, but the question is whether it is as accurate and as precise as the gold standard. Accuracy and precision will be the subject of our next presentation. By accuracy, we mean that the result of the test is near to that of the gold standard. By precision, we mean that whenever the test is repeated by the same person or reproduced by his colleagues, the results will be comparable to one another. Let's have a look on the performance of this shooter. In panel A, shots 1 and 2 are both away from the target, and they are away from each other as well, so they are neither accurate nor precise. In panel D at the bottom, both shots are quite near to the target, and to one another they are both accurate and precise. In panel B, we lack precision. In panel C, it lacks accuracy. Let's now shift to the clinician. We replace the shooter by this clinician. The new test will be accurate if it matches the truth that is supposed to be given by the gold standard, and it will be precise if the clinician receives comparable results whenever the test is repeated in the same patient or in patients with similar condition. For him, repeatability and reproducibility are what makes a diagnostic test reliable. However, he has to expect some lack of precision, giving a random error that deviates in one direction or in the other from the truth, but tends to nullify by the end. On the other hand, an inaccurate test, even if precise, will give a systematic error that will always occur in one direction or the other, and unless this systematic bias is overruled, we cannot speak about any agreement between the two methods. So the analysis starts by showing that any difference between both tests is statistically non-significant, which gives the green light to evaluate agreement, calculate an appropriate index, and test its statistical significance. All tests and indices shown above will be discussed, with practical examples calculated by hand or by online calculators, and most importantly, we will verify the conditions of application. We will note what should be reported as well as the correct interpretation. And good luck.